This video cast will show you how to create amortization schedule based on the mortgage payment calculator that we created in the previous video cast. So the first thing we're going to do is to figure out what is the beginning balance for our amortization schedule. It's going to be placed in I-5. So obviously, beginning balance is the same as the loan amount. So it's going to be equal to D8. And I'm going just to type it, D8, press enter. And that transfers the loan amount into the beginning balance that we will begin paying at the beginning of our mortgage. Now the ending balance is a bit trickier. First of all, we need to figure out what formulas we're going to use here. And I suggest to use the if statement and then present value statement as one of the arguments. So in this case, I'm going to show you how to use an embedded formula where you embed one formula within another one. So I'm just going to type in equals if, and now I need to see what my logical test is going to be, and I'm just going to compare the year number in which I'm currently is. So this is going to be year 1, then we'll move to year 2, 3, and so on. So right now it's year 1, and I'm going to compare this value with the term. So once I reached year 15, then I do not have to pay anything else, correct? It's only 15-year term. So the first thing I'm going to do is to type H5, which is our year we're in. I'm comparing it whether it's less or equal to our term, to F5. So I'm just going to type in less or equal to F5. And so this formula, when I copy it to the rest for the rest of the years, is just going to keep going and comparing it. Okay, year 1, it's definitely less than 15. Year 2, definitely less than 15. Year 15, okay, it's still equal to year 15, but when you move forward, then this condition becomes false. And so at this point, I will end my calculations, so I should not have any ending balance once the value of H5 is greater than F5. Now the only thing here is that you remember that when I use relative reference address, it's going to copy and change. So if I just leave it as it is, now F5 will become F6, then it'll become F7, and so on. So I want it to point always to the same cell, F5. So I'm going to make it as an absolute value, and I'm just going to add the dollar signs, or just press F4, and that'll input the dollar signs, converting this function, this cell address into an absolute cell address. So now I'm going to move to the next argument. I'm going to type in comma, which is argument separation sign. Now, what value I should have to demonstrate what happens if the first condition, the logical test, is true. So my true value is actually, for this purpose, I'm going to use the present value formula, which returns the present value of an investment, okay? So the total amount that a series of future payment is worth now. So obviously this will also adjust depending on the year that we're in. All right, so the first argument is going to be the rate. And our rate is actually indicated it's 4.125. And since we're talking about not annual rate, but monthly rate, I'm going to divide this by 12. So I'm going to type F4 divide by 12. And now again, if I start copying this formula in the row year 2, year 3, and so on, if I don't change this cell address to absolute cell address, then it'll transform it. Instead of showing it as F4, it'll start showing F5, F7, and so on. So I need to make it an absolute cell address. So again, press either F4 or just type in $signs. Okay. And once we're done with this, let's move to the second argument for the present value formula. All right, so the next one is going to be number of payments. So it's going to be F5, right? F5 minus H5. So that's how we're going to determine the number of years still left. And again, because there's 12 months in each year, we're going to multiply this difference by 12. So I'm just going to type F5 minus H5 and multiply by 12. Now notice that I'm using F5 as an absolute cell reference and H5 as a relative. The point being, I always wanted to show this specific value. So when I type F5, it always will go to this term number 15. Now, with each year, this value should be changing. So from year 1, that will convert to year 2, 3. So this is going to be a relative cell address, and it will adjust coming from H1. Then for this year, it'll become H5. Then for this year, it'll become H6, H7, and so on. All right. So the next argument is actually going to be the monthly payment value. Okay, so the third argument is payments. It's right here. So the first one was rate, then number of periods, and then periods for payments, and now it's just the value of the payment. So I can just indicate this value, F6. Okay, and again, this needs to be an absolute cell reference because it needs to stay put. Now, one thing we need to remember, when we created the formula for monthly payment, we used PMT function, and because it showed as a negative value because we actually owe the money, we changed the sign in front of the PMT function to negative, so to reverse the sign of the function, so it would show as a positive value in the mortgage payment calculator. So I'm just going to return to the original value, and to do this, I'm just going to enter a minus sign in front of the cell address. So it's going to be minus F6 as an absolute cell address. And I'm going to close the parentheses. And so now I'm done with my second argument for the if statement. So this is the first one, the logical test. This is what happens, what value I should display if the logical test is true. And now once we reach year 16, this value, the logical test, becomes false. And if this false, that means that I don't owe bank anything. So this value will become 0. And I'm just going to type the last argument as 0 and close parentheses. And so this is my ending balance for year one. That means that this is how much I'm going to owe at the beginning of year two, correct? So basically, beginning balance, the actual loan amount, minus the number of 12 payments, each payment consisting of this value. All right, so actually for the paid on principal for K5, now we just have to show the difference between I5 and J5. So this is the difference between I5 minus J5. So that's how much we paid on the principal while paying the monthly payment during the year one. Okay, and for the interest paid, we're now going to also use an if statement, and I'll just expand the cell so you can see it better. Right, so I'm going to type in if, and our logical test is going to be, I'm going to check if my I5 value is actually greater than 0. If it's still greater than 0, the beginning balance, then I'll keep paying. If not, then I'll need to stop, right? And that means that I also don't have any interest left, so there won't be any interest that we need to consider. So I5 greater than 0. So that's my logical test. I'm just going to check, okay, if this is greater than 0, then, and I move to the second argument separated by a comma, then actually the value in F6, the monthly payments, times 12, so how much I'll pay during the year. So let's type this in. So F6 minus multiply by 12, and again make sure that you use absolute value, absolute cell address for F6, because that's always going to be in this very cell. It can't move anywhere else. So if this again, if our statement is true, then monthly payment times 12, so that's an annual payment, minus K5. Okay, minus basically how much we paid on the principal, and that concludes our second argument. So this is just going to display the interest paid on the loan during the first year. And so if this statement becomes false, if the value in I5 is not greater than 0 or equal or less, then we don't have any interest paid, and I'll just type as 0 for the third argument. So now we need to figure out what the beginning balance for year 2 is going to be, and obviously it's just going to be the same as the ending balance for year 1, which is located in J5. So I'm just going to type in equals J5, press enter. And so now basically we are ready to start populating the other numbers. And I'm just going to use the autofill function and just apply the rest of the data. So in year 15, we actually see the beginning balance as 30,000, the ending balance as it should be at 0, the principal paid 30,000, and the interest paid of $677. Now the only things we have to calculate are subtotals, down payment, and total cost. All right, and so now we have to calculate the subtotals by using the AutoSum function. So I'm just going to click on AutoSum, press Enter, use the function or autofill feature. The down payment is obviously the same as it was in cell D7, so I'm just going to type equals D7. And so our total cost is going to be the down payment plus how much we paid on principal, K20, and how much we actually paid on the interest, L20. And so this number is exactly the same as we have in the mortgage payment calculator, the total cost. The total interest matches the value in L20. And this is our subtotal, how much we actually paid on the interest, which is exactly the value for the loan amount. So this concludes the video cast about how to create the amortization schedule.